Hello class, this is group number 8 and we are working in the lab number 3. The group number 8 consists in Jared Harper, Daniel Vite and Erin Martinez. The narrator is Daniel Vite. In this lab, we are going to demonstrate that it is faster and easier to find and simplify Boolean expressions using cardinal maps instead of equations using theorems. For this lab, we are working with a company called Road Riper Motor Company. This company creates cars and they are trying to implement circuits on their cars because they want to have better marketing and also to have cheaper productions because using circuits also make more solidness the cars. The company is giving us some instructions, some statements to know when the lights are on. They want to use the left back, and the front lights. So to start with this project, we are going to find when the outputs are having the lights on. In this case, we are having 11 statements. If we want to simplify these statements, we can use theorems, but it will take a long time. So instead of using theorems, we are gonna use cardinal maps. And just to remember, if we want to use cardinal maps, we need to use a cardinal maps for each one of the outputs. In this case, there are 4 outputs and it means 4K maps. The first thing, we are going to work with the left front light. We need to find and identify when the light is on. So there are 4 times when the light is on. So let's start. The first step is fill out the ones in the cape map. The second step is identify where it's on. And the third step, we can say find the unchanging variables. In this group, we can see that it's on when the left light is on and also when the clock is on. The left and the clock. Now, let's go to do the same with the left backlight. The first step is fill out the key map and then identify where it's on. In this case, we have 3 groups: the yellow, the green, and the red. Now, the third step is finding changing variables. In the first group, that is the yellow, we notice that it's on when the left light is on and also when the clock is on. In the green group, we can say that it's on when the stop signal and the right signal is on. Now, finally, in the red group, it's on when the stop is on and when the left is off. We can do the same with the other 2 cape maps. In this case, the right front light is gonna be on when the clock is on and when the red the right is on. In the right backlight, it's gonna be on in these cases. Now we have these statements and let's go to apply in a circuit. In this case, we can apply in Logisim. We can use each one of these in the circuit. We are gonna have 4 inputs and also 4 outputs. But we can see that this circuit is a little big. So we can simplify that. And also the company is asking us to simplify it. In this case, we can use ROM. ROM is so much easier to use it. To use it, we need to find where the statement is on. So for this, we can use the truth table from the beginning. And we can use the statements and these binary numbers, we can use them, instead of binary, we can use them in hexadecimal numbers. These numbers, we can put it in the room. And something important to know is that we need to know and understand what is the less significant bit. In this case, it's the clock. It's the 0. It means that it's going to be in the right. And also, it applies for the output. The less significant bit is going to be in the right back. In this way, in conclusion, we understood that using the cardinal maps sometimes could be more useful. In this case, the use of that method was useful in the practice. The second conclusion is that the use of ROM is better than GACE. Also, ROM is easier to program it. And finally, we can save money and time using ROMs. Thank you for your attention.